All right, today we're going to start the section on conversion between number bases. And in reality, you've already done this a little bit. You did it in section 4.2. You converted between base 10 and what other bases? Do you remember? 60 was one of them, base 60. The other one was 20. At least it was sort of base 20, right? It had this sort of a weird modification because those Mayans wanted to have 20 times 18 in there, so they had a number 360. Remember that? So we're going to use that same process when we do these particular ones, except that we're not using weird symbols. Okay, so we get to use regular numbers with one exception, and you'll see that when it happens. We'll get there. And then with the other exception that, so when we're done, we'll have mostly numbers and we'll have some letters, but we'll also be able to use any base. So there's nothing specific about 20s and 60s anymore. We can use anything. Okay? So the first thing I'd like for us to talk about is our base 10 number system. We've already talked about it a little bit. So why do we have a base 10 number system? We talked about that last time. Because why?
There's 10 numbers.
But why do we have 10 numbers? See, Tyler was at a disadvantage. He wasn't here, so he didn't get to see my visual. Do you guys remember? Nobody knows why we have a base 10 number system? 10 fingers. 10 fingers, right? And then we talked about the Mayans. When we talked about the Mayans, we talked about the fingers and the toes, actually, right? So we have a base 10 number system because we have 10 fingers. If we'd been born with some other sign and number of fingers, like 8, we probably would be using a base 8 number system. Okay? So that's actually the biggest reason of why the 10 is so common is because of that. Now, thinking about it with me, I want you to think, what is the first of our numerals in our number system? What's the first one? It's actually 0. So we have a numeral 0, and then we have 1, 2, all the way up to where?
9.
Right. So we have 10 numerals that starts at 0 and it ends at 9, and we do not have a numeral that is the numeral 10, do we? We have something that we write down and call a 10, but it's not a numeral because it takes how many numerals to write the number 10? 2. So once we run out of our 10 numerals, we actually get to a 2-digit number that has 2 independent numerals. And it always goes 1, 0 next, doesn't it? Okay. And then after that, we would go to, well, what's after a 10? 11. We do a 1 and a 1. And then we go all the way up until we run out of numerals again. What's the last place we would run out of numerals?
19.
19. And then we would have to change the number again to the number 20. Everybody knows this is how it works, but I'm bringing it to your attention because it's going to work the same way no matter what base we're in. So once we run out of numerals here and we get to 19, then we have to change the first of the 2-digit numerals to the numeral 20. And then eventually we would run out of 2-digit numerals. What's our biggest 2-digit numeral?
9.
Our 2-digit number? 99. And what happens when we run out then?
You
We add an extra digit and we have 3 digits. Okay, the same thing's going to happen with any of these bases. Okay, when we run out of numerals, we increase the number of digits we have. So let's take a look at a base 5 number system. A base 5 number system was actually used, I can't remember which of the ones it was. It's not in our book, but it has been in a book I've used before, where base 5 was actually the number system used by a group of people. And why might they have used base 5? Because it had one hand, right? And they didn't actually, they actually had numerals that they didn't use, like our numerals and whatever, but it was a base 5 system. So if you have a base 5 system, how many numerals do you think you have? 5, because in our base 10 system we have 10. So the numeral would start with, again, 0, but where would it stop? 4. So there is no 5 in base 5, is there? Just like there's no numeral for 10 in base 10. I have now run out of numerals because I've got all 5 of them up there. So what happens in our system when we run out of numerals? What happened? I need 2 numerals put together. And what is the first 2 numeral number? In our system, what is it?
10.
It was 10. And in the base 5 system, it will be as well. We won't read it as 10. We'll read it as 1, 0. Okay? When you run out of numerals, you have to create a 2-digit number. The first number is a 1, and the next one's a 0. Okay? I'm going to give you an example of this, and you know what, now's probably as good a time as any to do it. Let's actually write in a few more numerals, and then I'll give you an example of a base 5 number system. All right, so what would come after 1, 0? We're going to write down a few more. 1, 1, and then 1, 2, 1, 3, 1, 4, 2, 0, right? I ran out of numerals, so I have to increase the first one to be one larger, and the last one becomes a 0. All right, so let's give an example of how we could use this. And we're going to do it with money. So we can do this pretty well with our money, but we don't use all of our coins. All right, so imagine that we had the penny. What else? What do you think? A nickel? Dime's not going to work. We need a quarter.
Quarter.
Okay? So a penny's worth what? 1. And what happens when you end up with 5 pennies? You change it into a nickel, right? You don't actually give somebody 5 pennies if you can avoid it. Think about if you were a cashier exchanging money back to somebody. You don't give them 5 pennies. They don't want 5 pennies, right? I don't know. I'm the one who would actually give you extra pennies not to get pennies back. You guys know what I'm talking about? Some of you who've cashiered know what I'm talking about. You look at me weird whenever I do it for you. You look at me like, how's that going to help me? And I'm like, just put it in the cash register, it'll be fine. All right, so we don't do 5 pennies. We'd give them back a nickel. Same thing happens if we had actually, again, pretend like we don't have a dime at all, okay, just for the sake of what we're talking about. Pretend there's no dimes. If I actually wanted to give somebody back 25 cents, I wouldn't give them back 5 nickels, would I? Not if I could avoid it. I would give them back a quarter, right? Same thing. That's what this is doing for us, right? I don't actually ever give things back in 5s. That's what happens in base 5. I never give somebody back 5 of something. I would change it up to the next number system. Up to the next value in their number system. Okay, so it's a base 5. Let's do base 7 and base 12, and then we're actually going to talk about a couple of other number systems that you're familiar with that you probably aren't aware that you're familiar with. So let's do base 7 first. What do we start with? 0. And what's our last numeral? A 6. So are there 7s in base 7? No. Once I get to 6, I run out because I've got 7 numerals there already. Those are my 7 numerals. What comes after a 6? A 1 and a 0. Yeah, I know it looks like a 10, but it's 1, 0. And then what will happen? 1, 1. 1, 6. And then 2, 0. And we keep going, right? So let's pause for a moment just to ask ourselves a question. What would the biggest 2-digit number be in base 7? 6, 6, wouldn't it? Because the largest numeral is a 6. So if you've got a 2-digit numeral, the largest one would be 6, 6. Much like our 9, 9, right? What would the largest numeral have been in base 5? 4, 4. Yeah. Kind of crazy, huh? It's a little different way of thinking about it. Let's do base 12. What is different about base 12 than the other 2 examples that I've already given you? It's got more digits than actually our base 10 would have, doesn't it? Because I should have how many digits? Well, 12, because it's base 12, because we start with 0. Yeah. So let's start with 0, and we'll talk about what happens when we get to the end of 9. So write down up to 9. Okay, so when we get to 9, I need a digit, like a 1-digit thing, like one thing to write down, not 2 beside each other, but I need to write down one thing that represents the number 10, because there is a 10 in base 12. There's also an 11, like Jesse said, in base 12, right? Got to have a 10, got to have an 11, but I don't want to write it as 2 digits beside each other, because that just starts to get confusing, because that's 2 digits, and I need 1 digit. So what we're going to do is we're going to go into the alphabet. Okay, we're just going to start at the beginning. The first letter would be 10. So that's the letter A. So A is our 10. Not 10 as in 1, 0, but it actually means 10 of something. Okay, 10 apples or 10 whatever. And then I need an 11, so I also need a B. Okay, that's worth 11. So if I ever see a B in the middle of a number, it's worth 11. It doesn't matter what place value system, base, anything I'm in. If I see a B, it means it's worth 11. Okay? what would happen when I run out of digits now?
You gotta start doing double.
I need a double number, which would be exactly 1, 0. Okay? So I'm doing the same thing I did before. I ran out of digits. I just happen to have a couple of letters that I'm calling digits. Okay, but I run out now. I've got my 12 digits on the board. So after B, I go back and do the exact same thing I did in the other bases. I've got a 1, 0. And then I've got a 1, 1, all the way up to what? Right? I'm going to get all the way up to 1, 9. What's going to happen after 1, 9? Say it loud for me.
1A.
I'm going to get 1A. That's exactly right, because I've got an extra numeral in this system, right? I've got an A. So I'm going to get a 1A, and then what would happen? 1B. And then I've run out again, because I've extended all I can, and then the next one would be 20, yeah. Okay, so what's the largest two-digit number in base 12? Say it louder for Tyler.
BB.
BB, right? Because the largest digit's a B, so if I've got a two-digit number, it would be BB. What would come after BB? 100. Yeah, Tyler, you're about to say it right, but 100. Three-digit number. The first number's a 1. The next two become zeros. Okay, so we're going to work a little bit on that idea of going forward and backwards with the number system. But you actually know a base 12 number system. What do you know that's base 12? Say it for me louder, Clinton.
Like ounces and pounds.
Ounces. Okay, so ounces would be base 16. That's a good example, though. I hadn't thought about that one. Ounces is a good base 16 example. I was going to mention base 16 in a minute.
Oh, inches?
Time and inches are both done with 12. So like inches to feet, we have 12 inches in a foot. You would never tell somebody that you have a 12-inch long something. You would change it into feet, wouldn't you? The clock is also a base 12 clock, sort of. With the hours part of it, it is, right? If you actually just talk about the number of hours or hours as whole numbers, then you can do base 12 with the clock. But it's a little weird because we actually have a 12 and an 11 and a 10, like the numbers are still there. And we actually have the 12, which is weird instead of having a 0. But it has the same kind of a feel to it. It is a base 12 system. If you did military time, you would be doing base 24. Does anybody else know any other bases that are actually used? There's at least 2 others that are very commonly used.
Base 12.
Besides base 12. Besides the ones we've done, there's actually 2 other common bases.
Would it be base 8 or the number base 16?
No, I don't know of any particular examples for base 8. Do you?
I don't know. Just
No, okay, that's okay, because I don't know all the bases either. I mean, examples for them.
No, base 16 is used for the hexadecimal.
Base 16 is used for hexadecimal, and you gave an example with the ounces, which is actually a really great one too, I hadn't thought about before. What is hexadecimal used for, Tyler? Do you know? Coding in,
HTML.
right, computers, right? Computer coding. And there's another computer coding one that's used. Do you know what? Binary, base 2. Yeah, base 2 is also commonly used. Base 2 is very interesting because what is base 2? What are the numerals in base 2? 1 and 0, and that's it, which means you've got really long numbers because you only got 2 digits. I mean, all you can do is put 1s and 0s together. You're not going to be able to have a very large value without having a large number of digits. All right, so let's do the first example with these. The first example we're going to do is going to have the question where we're trying to find, in the same base, the number before and the number after the one that's been given. All right, so I've given you a couple of examples where one direction's easy and the other direction takes a little bit more thought. Okay, so let's do the one for base 5. In base 5, what number comes before 1, 4? We already wrote it down, so you know. 1, 3. Now, here's the deal. Whenever we're writing the number, we have to put the subscript next to it so we know what base we're in. So if you just leave this as 1, 3, it means it's in base 10 because you haven't told me otherwise. So if you mean that this is in base 5, you need to write down that is in base 5. And your book, and there's other ways to do it, but your book uses the subscript with the actual word written down there. And when you do this in My Math Lab, there is a button in the little toolbox where you can do subscripts. You may have seen it, you may not have. That's the button you'd want to use so that you can actually put the subscript and write in the word 5 or whatever word it is you need to write. Okay? All right. What's the number after 1, 4? Good. So after 1, 4 is not 1, 5, right? It's 2, 0, base 5. Okay, so far so good? All right, so number 2 is one of those weird ones because it's got a letter involved. Okay, we're not at this point doing any conversions or anything, although we're going to get there very quickly. But we do have A00. On this one, the easiest one to find is the number after. What is the number after A00? A01, right. Again, base 12, written as a subscript. But the number before takes a little more work. So how are we going to find the number before A00? Why don't we turn it into something that we understand and feel more confident in doing? Like, let's just pretend that that didn't say A00 and it wasn't base 12. Let's pretend it said 900 and it was base 10. What's the number before 900? Okay, so this is not the same problem, but it is a similar one. We'd have 899. So what happened to the first number? It became 1 less, right? And what happened to the last 2 numbers? Okay, so they became the largest value that we have in that system, right? Do you guys see that? So you're right, they added 9, right? That's one way of thinking about it, but that doesn't really correlate very well with base 12. An easier way to think about it is they became the biggest thing we could have. Make sense? So I heard a couple of you tell me what would happen with the zeros. Let's start with the A. If I need to take the first number and it becomes 1 less, what's 1 less than A? 9. Does that make sense? Okay. And then my zeros need to do exactly what these zeros did. They need to become the largest value in that base system. And what's the largest value in base 12? B. So this becomes 9B, B, base 12. When you're working with these, like the numbers before, the number after, the easiest thing really to do is to change it and think about, if you're struggling on one, like this one was a little bit weird, right? Looks a little bit odd. First time you've seen it, you're trying to go backwards. How do you go backwards? It's other base stuff. Figure out what you would do in our number system. And then that gives you a clue of how you would figure it out in that number system. Are we all good so far? Okay. What we're actually going to do now is we're actually going to convert. I want to show you what the directions are, and I want you to see that I've struck through them. And I did on your notes too. The directions in your book will say this exact same thing. They will say convert each number to decimal form. Decimal form is base 10. Decimal means deci, right? 10, base 10. To decimal form by expanding in powers, and it says, and by using the calculator shortcut. Okay? We're not going to do the calculator shortcut. What it does is it really hides what's going on, which means then you've got this great feature that you can use, but you have no clue why it's working. It's not real helpful, okay? So I'm going to show you how to do expanding by powers so you can see how it works. And I'm doing an example of base 2 and base 16 in honor of the 2 base systems that we spoke of earlier, right? All right, so what I'm going to do is I want you to think about these in their base systems in expanded form. We did expanded form in section 3. And I've got a 1, a 0, a 1, and a 1, and this is in base 2, right? So in base 10, each of these place values has a power of 10 in it, right? We had 10 to the 0, and 10 to the 1, and 10 squared, and 10 cubed, and that's all good. But it was in tens because it was in base 10, and this is in base 2. So I'm going to use powers of 2 because I'm in base 2, right? So this is 2 to the 0. This is 2 to the 1. This is 2 squared, and this is 2 cubed. That is the place value that they're in because this is base 2, powers of 2. So the way that we turn this into our number then is that we take the number that's in that place value, the 1, and we multiply it by the value of the place value, just like we did in expanded form in section 4.3. Nobody asked any questions, so I hope you understood what that was doing when you did it. And then we add to that the next one. And I'm going to write it in even though I know it's a 0, just so that we can see how it looks in general. You have a 0, and then you have that times 2 squared. Then you have another number 1, the third number in this, third numeral in this number. And that's times 2 to the 1. And then you have the number 1, and it's times 2 to the 0. All right, so using this, I'm just going to take a moment to write out what they are, just so that you can see them a little bit more clearly. What is 2 cubed? Somebody said it. It's 8. What is 2 squared? 4. 2 to the first? 2. And 2 to the 0? It's 1. Anything to the 0 power is 1. So what I really have here is I have 8 plus 0 plus 2 plus 1. Does that make sense? You do not have to write both of these out. If it helps you to see it, that's great. But one of them needs to be written out so I know how you got from this to your answer. You've got to write something down for me that shows me that you understand that this is a multiplicative feature and that you didn't just look on somebody else's paper. Check the back of the book or whatever. Okay, I want to see that you know what you're doing. That's what this expanding by powers part of this direction right here is referring to. Okay, we're expanding by powers. So what is 8 plus 0 plus 2 plus 1? It is 11. We are 11 in base 10, which means you can leave it written as 11. Or if you want to be real careful so that you don't forget it ever again for this section or whatever, you could write the number 10, like the word 10, beside it as a subscript. Okay? But 11 is actually the value of this. Okay? All right, let's do one more, and then I'm going to make one up because I want you to see how this would work with money, the example I gave you guys with money earlier. All right, A, B, C, D, base 16. How cool is that? We got lots of letters going on here today. All right, so we have 4 digits, and this is base 16, so these are powers of 16. So 16 to the 0, I'm not going to have a space. Let's try that again. All right, 16 to the 0, 16 to the 1, 16 squared, and 16 cubed. All right, the first digit is an A. What value is A? It is 10. So I have 10 in the 16 cubed spot. Then I have a B. What value is B? 11. So I have an 11 in the 16 squared spot. C is 12. And D is 13. Okay? That's what I would have. And then I need each of these multiplied, right? So these two get multiplied. 11 and 16 squared get multiplied. 12 and 16 to the first get multiplied. And 13 and 16 to the 0 get multiplied. So we're going to write that out. I'm only going to write it once this time. But I have 10 times 16 cubed plus 11 times 16 squared plus, and I'll run out of space, so let me just move down here now, 12 times 16 to the 1 plus 13 times 16 to the 0. And then you can use your calculator to fill that in. Some of you have calculators, oh, it just stopped working, didn't it? Some of you have calculators that will just let you enter all this at one time. And if you have that kind of calculator, use it. That's great. I don't have a problem with that at all. Okay? Some of you don't, and you have the scientific calculators where you have to enter it piece by piece. Just make sure you're writing down those pieces as you go, and you'll be fine. Okay, so it's not going to show you what I'm seeing on here, but you know what it says, right? Did anybody put in their calculator and find out what it is? Please. Mackenzie's going to for us. Brian's going to give it a try. Tyler, you want to try too? All right, so what was our answer, Tyler? 43,000?
984.
981. All right, great.